everyone, in Algebra 3, this is going to be your questions on lesson 62. We are going to get started on the first problem, which is number 3. So it says 5 marbles, 4 white marbles, and 2 green marbles are placed in a row. How many distinguishable ways can they be arranged? So for number 3, distinguishable permutations is n factorial over the number that are like factorial. So in our problem, I'm going to have a total of 5 plus 4 plus 2 marbles, which would be 11 factorial. I have 5 marbles. Sorry, this should be 5 red marbles. So then I have 5 red marbles that are alike, then I have 4 white marbles that are alike, and then 2 green marbles that are alike. So in total, 5 plus 4 plus 2 is 11. Now when I multiply this out, I'm going to do 11, 10, 9, 8, 7, 6, and then 5 factorial. I'm going to have 5 factorial, 4, 3, 2, 1, and then 2 and 1. So the 5 factorials are going to cancel. Then I have 4 times 2, which is 8, and 3 times 2, which is 6. So when you multiply it out, we can just do 11 times 10 times 9 times 7, which will give us 6,930 would be your result. So distinguishable permutations, that's the formula for that. Moving on, we're going to look at number 4. So number 4, it says, how many ways can 4 boys and 1 girl be arranged in a row if the girl insists on sitting in the middle? So for number 4, this one's going to be a little different because it's telling us that the girl has to sit in the middle, but it doesn't say specifically where the girl's going to sit. So there's going to be 5 total places that she can sit, or sorry, 5 boxes because there's 5 total people. But I'm going to say that the girl could sit here. The girl could sit here, which is the middle spot, or the girl could sit here. Because all of these spots are actually in the middle, technically, it's not on the end. So if I'm identifying that the girl will sit there, that means there's only one option that I'm choosing from those spots. Then for the rest of the spots, I'm choosing from the 4 boys. So I'd have 4 boys to choose from, then I'd have 3, then 2, then 1, because repetition is not permitted. All the other boxes would be the same, 4, 3, 2, 1, then 4, 3, 2, 1. So 4 times 3 is 12, times 2 is 24. So if all of these have 24, my answer is going to be 72. There's 72 different ways we can rearrange those 5 people if the girl insists on sitting in the middle, and that's number 4. Now moving on, we're going to look at number 6. So for number 6, we have Daisha could row 12 miles downstream in 1 hour less than she could row 6 miles upstream. What was the speed of the current in the river, and how fast could Daisha row in still water if the speed of the current was 1/2 the speed Daisha could row in still water? So the current, number 6, is half the speed of the boat. I don't want to deal with a fraction, so I'm actually going to change this to B is equal to 2W. It says the distance downstream is going to be 12. In 1 hour less than she could row 6 miles upstream, so the distance up is 6. And the time down is going to be the time up minus 1. Now I have 2 equations. I have my downstream equation, which is going to be B plus W times TD equals DD. Then I have my upstream equation, which is going to be B minus W times TU equals DU. Now I'm going to plug in the numbers that I have. I have b is equal to 2w, so that would be 2w plus w times td, which is tu minus 1, equals dd, which is 12. Now if I add the 2w and the w, I get 3w times tu minus 1 equals 12. But what I want to do is I want to get rid of that 3. So I'm going to divide this equation by 1/3 and then distribute the w. So that would give me WTU minus W equals 4. Now I'm going to do this equation over here. My B is going to be 2W minus W times TU equals 6. Now 2W minus W is actually just going to be WTU is equal to 6. Now I can take that and easily plug that into this equation over here, which would give me 6 minus W equals 4. Move the 6, so I get the speed of the current W is going to be equal to 2. If the speed of the current is equal to 2, then I can find the speed of the boat in still water is going to be equal to 4. Moving on, we're going to look at number 8. So for number 8, it says the number of reds vary directly as the number of purples and inversely as the number of whites cubed. There were 200 reds when there were 50 purples and 10 whites. How many reds were there when the number of purples was increased to 60 and the number of whites was decreased to 5? So for number 8, I'm going to start with this equation. It says reds vary directly. So I'm going to start off with R1 over R2. When it says directly to the number of purples, that means that the P1, purple 1, and then purple 2 will go in the numerator and the denominator. But it says inversely as the number of whites cubed. So that's when the W2 comes on top and the W1 goes on bottom. So inversely means you flip it. And we have to cube the whites. Now you're going to plug in the variables that they give us. So it says 200 reds, so initially 200 reds, 50 purples, oops, and then over whites cubed, and that would be 10 cubed. Erase this line. Then it says how many reds were there, so we're solving for R2 when the purples was increased to 60, so that would be 60. And the whites was decreased to 5, so this would be 5 cubed. So now I'm going to cross multiply. So I have 50 times 5 cubed, which is 125, x equals 200 times 60 times 10 cubed, which is 1,000. Sorry, I had to write over that last problem. And then we're going to divide both sides by 50 times 125. Now I can do this all in my calculator. So I do 200 times 60 times 1,000. And then I'm going to divide that by, in parentheses, 50 times 125. And that will give me 1,920 reds. So varied directly versus varied inversely. Now, a lot of you asked for number 12, and in this lesson for number 12, we're actually going to skip that problem just for this lesson only, because if you count the number of variables, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And in order for us to do that problem by hand, we would have to split that one up into 4 equal groups, and 9 does not divide evenly by 4. So for number 12 only, or this problem set only, you can skip number 12. Now moving on to number 14. So for number 14, I have tangent squared theta is equal to 1. The first thing that I'm going to do is I'm actually going to take the square root of both sides so that it's just tangent. So tangent theta would be equal to plus or minus the square root of 1. Should be 1 or negative 1. I can split this into two separate equations. So I have tangent theta equals positive 1, and then tangent theta equals negative 1. Remember that you can always put your numerator over positive 1. Now I need to find out where tangent is positive and then where tangent is negative. So all students take calculus. All students take calculus. So I know that everything is positive in quadrant 1 and that tangent is positive in quadrant 3. So I'm going to draw a triangle in quadrant 1 and 3, labeling my sides opposite over adjacent. So 1 over 1, negative 1, negative 1. I know that that's a 45-degree triangle. So for quadrant 1, that would be a 45-degree triangle. In quadrant 3, it's also 45, but I have to add that to 180, so it would be 225. Now for my second one, if it's positive in quadrants 1 and 3, that means it's going to be negative in quadrants 2 and 4. Opposite over adjacent, opposite over adjacent. It's still a 45-degree triangle. So for quadrant 2, I'm going to subtract that from 180, which would be 135. And in quadrant 4, I'm going to subtract it from 360, which would be 315. And that would be your result for number 14. Now moving on, the question is for number 16, not number 15. So for number 16, I see a minus sign between my logarithms, which means that I'm going to divide. So that would be log 7 x plus 9 over x equals log 7, 7. Now to get rid of the log 7, I'm going to raise both sides to the power of 7. So the log 7's cancel. And now I'm going to cross multiply. So that would be 7x equals x plus 9. That would then give me 6x is equal to 9. And when you divide both sides by 6, you would get x is equal to 3 over 2. And that would be your result for number 16. Now moving on, we're going to look at number 17. So for number 17, I think this is written wrong. Yeah. So for number 17, I actually have 6 to the 2 log 6 of 2 plus 5 log 4 of 4. So this 2 is going to become the exponent of the 2. This 5 is going to become the exponent of the 4. So really I have 6 to the log 6 of 2 squared plus log 4 of 4 to the 5th. Now if my log's base or the base is the same as the log's exponent, those actually cancel, as well as this log is going to cancel. So I have 2 squared, which is 4 plus 5. So my result is 9. So the laws of logarithms do apply to your exponents. That is something you do need to know. Now moving on to numbers 19 and 20. So we're going to look at in our book. So if I look at number, I'm going to look at number 19 first. I need to write this in terms of a cosine function. So for 19, I'm going to have y is equal to a plus b cosine c of theta minus d. And that's actually going to be the same for both 19 and 20. So the first thing that I need to find is a. So that's going to be this value in between 3 and negative 5. So for 3 and -5, we're going to do top plus bottom value divided by 2. That's how you find the midpoint. So -2 divided by 2 would be -1. B is the amplitude, so the distance between the top line and then whatever I got for A. So it'd be 3 minus whatever I got for A, and that would give me 4. For C, it's going to be 360 divided by the length of the period. So for the length of the period, we can actually calculate that either from peak to peak or base to base, or one full rotation. I'm actually going to do it from, if you see it peaks at -225 and it's peaking again at 135, but that total distance would be 225 plus 135. And that's going to give me a result of 1. Now, if I want to make this a positive cosine function, that means it needs to peak at the origin, but currently it's peaking at 135. So I need to actually shift this whole cosine function over 135 degrees. So I actually have y is equal to -1 plus 4 cosine C we don't have, and then my phase shift is I'm going to shift it over 135 degrees so it now peaks at the origin. And that would be your result. Now quickly moving on to number 20. That one's already a cosine function, so I'm going to already use this equation right here. But what I need to do is I need to solve for what A, B, and C are equal to. So for A, I'm going to calculate that by doing top plus bottom divided by 2. So the top is 2, and the bottom is -8. So 2 plus -8 divided by 2 would be -6 divided by 2, which is -3. Then for B, it would be top value, so the top value, which is 2, minus that value you got for A, which is -3, and that would give me 5. Now C is going to be the tricky one because this is in radians, so it's going to be 2 pi divided by the length of the period. Notice that it's peaking at 0, and then it's peaking again at 6 pi. So the length of the period would be from 0 to 6 pi, which would be 6 pi. So 2 pi divided by 6 pi would actually just be 1/3. Now I don't have a phase shift because this is already a positive cosine function. So my answer is just going to go back to that equation right there, which is going to be y is equal to A plus B, which is 5, cosine, yikes, 1/3, and it would just be x because we don't have a phase shift, and that would be your result. Okay, so that's your result for numbers 19 and 20. Now we're going to move on to number 21, which we are going to have to find the area of a trapezoid. And it says to find the area of the trapezoid in square centimeters. And if you notice that this is currently in meters. So I have this trapezoid here. The angle is going to be 40 degrees. My slant is 0.3 meters. My top is 0.25 meters. My bottom is 0.4 meters. So the first thing that I'm going to do is I need to actually find the height of this. And before I do that, I'm going to use sine, because sine is opposite over hypotenuse. So sine of 40 is equal to opposite, which is the height, over the hypotenuse, which is 0.3. But I do want to change that from meters to centimeters. So 0.3 meters to centimeters would be 100 centimeters is equivalent to 1 meter. So I know that I'm just going to move the decimal point over 2 spaces, so that would be 30. So move the decimal places over 2 spaces for all of these. That will change it from meters to centimeters. So now I'm going to solve for the height, and that would be 30 times 40 sine equals. So my height is going to be approximately equal to 19.28. Now I'm going to leave that in my calculator because I'm trying to find the area of the trapezoid, which is 1/2 the height times base 1, which is 25, plus base 2, which is 40. So that would be 65. So I'm going to take my height in the calculator. I'm just going to multiply that by 65 and then divide it by 2. And that would give me the area is equal to 626.72, and that would be centimeters squared because we converted it out from meters to centimeters. If you did not convert yours from meters to centimeters, you would need to do that in the end. Okay, moving on, we're going to look at number 23. So for number 23, we're going to find the area of the segment bounded by an arc of a measure 2.44 radian and the chord which joins the endpoints of the arc in a circle whose radius is 6 centimeters. So for the area of the segment, we actually have a formula for that. And in radians, it would be x over 2 pi times pi r squared minus r times r sine of x divided by 2. Now they give us the radius and they give us the radian measure, which is 2.44. You should notice that these pi's are going to cancel, so it'd be 2.44 over 2 times 8 squared minus 8 times 8 sine of 2.44 divided by 2. Now what I'm going to do here is I'm actually going to do this portion first so I can do the whole thing in the calculator at once. I do need to change this from degrees to radians by pressing the DRG button, and then it says RAD. So because this is in radians, we have to change it in our calculator. So I'm going to plug this in, 2.44 sine times 8 times 8, and that's going to be divided by 2. So that's going to be equal to 20.6539. And then I'm going to make that negative, because 2.44 divided by 2 would be 1.22. So I'm going to do plus 1.22 times 64, and the parentheses equals. So I just subtracted this value that I got from what I got from here. So which was, I did 1.22 times 64, and I did that in parentheses. So my result is going to be 57.43 centimeters squared. And if you don't have that formula written down, I would write that down as area of a segment. Now moving on, we're going to look at number 24. We actually need to graph both of these. And the first one's going to be a parabola. And this, because it's squared, it's going to be centered at -3. So -3 is going to be the axis of symmetry, because remember you said x plus 3 equal to 0. And it's starting at 0 because there's no plus k. So it'd be over 1, up 1 from there, and then over 2, up 4. So you should have a parabola that looks something like this. Then for my line, it's going to be at +2, and the slope is down 1. Well, down 1 to the right 1. So that should look something like this. And we are going to be shading the region. So it says below, less than, below the parabola. So that would be everything down here, or everything outside of it. And then everything below the line, which would be everything here. So your answer is the part that's shaded by both, which would be everything outside the parabola and then under the line. So this would kind of be your result right here. Under the parabola, but outside of the line. It was kind of hard to see because I used the same color pen, which was not the smartest decision. Now moving on, we're looking at number 25, which is 2 times sine of 19 pi over 6 times cosine of 19 pi over 6 minus sine of 19 pi over 3. So the first thing that I'm going to do is I'm going to create my snowflakes for these. First one will have 6, so 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And the other one will be 3, so 1, 2, 3, 1, 2, 3. So this would be 0. 19 pi over 6 means you're going to start counting in quadrant 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That means we are in quadrant 3. When the denominator is 6, it's going to be a 30-degree triangle. So this would be negative root 3, negative 1, and 2. Then for 19 pi over 3, counting from 0 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Which puts me back in quadrant 1. When the denominator is 3, it's a 60-degree triangle, so this would be 1 root 3 and 2. So now we're doing sine of this triangle, which would be opposite over hypotenuse. So that would be negative 1 times 2, or negative 1 over 2. Then it would be adjacent over hypotenuse would be negative root 3 over 2. Then minus the sine of this triangle, which is opposite over hypotenuse, which would be opposite over hypotenuse. Now the 2 and the negative 2, or the 2 and the 1/2 would actually cancel. So I have negative times a negative, which is a positive. So that would be positive root 3 over 2 minus root 3 over 2, meaning your result would be 0. Now moving on to number 26. So for number 26, we have evaluate tangent squared of negative 390 plus 1. Well, negative 390 is greater than 360, so I have to add 360 to that, which would actually give me negative 30. So a triangle in quadrant 4 with a 30-degree angle would give me an adjacent of root 3 and opposite of negative 1 and a hypotenuse of 2. Now I'm doing the tangent of that triangle. Tangent is opposite over adjacent. So that would be negative 1 over root 3, but I would need to square that. Negative 1 squared is 1, root 3 squared is 3, and I'm adding that to 1. So your result is either 4/3 or going to be 1 1/3 for number 26. And then finally on to your last one, which would be number 28. It says use the locus definition method to find the equation of the line equidistant from those 2 points. So what you're going to do, the locus definition method, is actually that long equation, which is going to be x minus x1 squared plus y minus y1 squared equals x minus x2 squared plus y minus y2 squared. So now my x1 is going to be negative 4, so that would be x plus 4 squared. My y1 is also negative 4, so that would be y plus 4 squared equals x minus 6 squared plus y minus 2 squared. You need to multiply this whole thing out. So that would give me x squared plus 8x plus 16 plus y squared plus 8y plus 16 equals x squared minus 12x plus 36 plus y squared minus 4y plus 4. So it says to write this answer in general form, meaning we have to set it equal to 0. So all your x squareds and your y squareds should cancel. I'm actually just going to move everything over to the left-hand side. So I'm going to add 12x, add 4y, and 36 plus 4 is 40, so I'd subtract 40. 8 plus 12 is 20, x. 8 plus 4 is 12, y. 16 plus 16 is 32, and then minus 40 would be negative 8. But if you look at this equation, all of those variables are divisible by 4. So I'm actually going to divide this equation by 4 so that your result becomes 5x plus 3y minus 2 equals 0. And that concludes your questions from lesson 62. I hope you guys all have a great day. Bye.